Hi students, MCQ number 22. A Carnot engine whose sink is at 300 Kelvin has an efficiency of 40%. By how much should the temperature of source be increased so as to increase its efficiency by 50% of its original efficiency? So very interesting problem and very important problem which has been asked many times in the previous competitive exams. Understanding the problem is very important. So my dear students, first I will write the given information. The sink is at 300 Kelvin. So in step 1, in step 1 I will take the temperature of the sink, that is denoted by T2. So this is equal to what? 300 K. Efficiency is equal to 40%. So 40% is equal to 40 by 100, that is equal to what? 0.4. So I will find out what is the source temperature. First in the case 1, what is the source temperature? I will find out. So efficiency is equal to 1 minus T2 by T1. So this implies 0.4 is equal to 1 minus 300 divided by T1. So this 300 by T1 shall be taken to the left hand side. 300 divided by T1 is equal to 1 minus 0.4, that is equal to 0.6. Therefore T1 is equal to 300 divided by 0.6. This is equal to 3000 divided by 6, and 30 by 6 is 5. So this is 500 Kelvin. So for the efficiency 40%, the source temperature should be equal to 500 Kelvin. Are you understanding up to this? We have found the temperature of the source in the first case when the efficiency is only 40%. Now what is given in the second part of the problem? By how much should the temperature of the source be increased? So in the second case, more than 500, we are going to increase the temperature of the source alone. That means sink temperature remains the same only, is it not, in the second case? So as to increase its efficiency by 50% of its original efficiency. Very important here. See, quickly you should not misunderstand that in the second case efficiency is 50%. It is not increased to 50%. Understand, it is increased by 50% of its original efficiency. That means already it is having a efficiency how much? 40%. What is 50% of 40% is 20%. So in step 2, I will write here step 2. So in step 2, the sink temperature remains the same. So 300 Kelvin. Source temperature T1 dash I have to find out. So here we use the symbol T1. So in the step 2 I am going to use the symbol T1 dash. And the efficiency in this case, here efficiency is equal to 40% plus 50% of 40%. So that is 20%. So this is equal to 60%. That is equal to what? 0.6. Understanding this is very important. Have you understood? So efficiency in this case is equal to what? 0.6. Now using the same formula, so efficiency eta is equal to 1 minus T2 divided by T1 dash. So this implies 0.6 is equal to 1 minus 300 divided by T1 dash. So 300 divided by T1 dash is equal to 1 minus 0.6, that is equal to 0.4. Therefore, T1 dash is equal to 300 divided by 0.4. So this is equal to 3000 divided by 4. 3000 divided by 4 is what? 750. So 750K. Now, what is the question? By how much should the temperature of the source be increased? That means, comparing with the first case, source temperature 500K, by how much the temperature should be increased? That means we have to find the difference between T1 dash and T1. Understand that? Therefore, increase in temperature of the source. Okay, increase in temperature of the source is given by T1 dash minus T1. So this is equal to 750K minus 500K, and that is equal to 250K. This is the answer. Okay, option A itself is the correct answer. Therefore, option A is the correct answer. So such questions are extremely important. You have to practice similar problems given in various practice books. Okay. So my dear students, I hope you must have understood well. Fine.